Good morning, Year 8. Hope everybody's fine and dandy and tickety-boo. Today we're going to have a quick look at data representation and more specifically sound. Lesson objectives are to learn the difference between analog and digital sound, and then more importantly in terms of the binary anyway, learn how sound is stored digitally. So what is analog sound? Analog sound is magnetic or vinyl media, for want of a better phrase. So back in the day we had tapes that look like these that hold the information magnetically. They can hold speech, they could hold video games, they could hold sound. They would run through a tape deck and that would be played through. So those held it magnetically. We also have vinyl records which use a needle. They store it in an analog fashion as well. What is digital sound? Something you're much more familiar with. iTunes, Spotify, SoundCloud, CDs, all stored in the music digitally. MP3 files, that sort of thing. But here's the difference then between analog and digital. Digital is more portable. It's on your phone, or it's doesn't have a Wi-Fi. It's easy to share. You just click a button. You don't have to send a vinyl record to your mate's house or drag it around with him. You can just, if the file's small enough, you can email the actual file. If not, you can share a link. It's easier to store. You can have MP3 files. Say 5 meg for a tune. You can have hundreds on your phones these days because there's gigabytes of storage on them. The sound quality is often better. That's what the file's supposed to say. A lot of music fans will prefer vinyl because they claim it's better. But to the untrained ear, the sound quality is better because there's no interference. There's no, tapes, for magnetic tapes, for example, can wear out over time and become distorted. That sort of thing. They can lose audio fidelity, they call it. And it's easy to mix with other formats of media. If I've got an MP3 file, I can easily add that to a video. I could add audio underneath my voice now. Not so much if I had an audio sample just on a magnetic tape. It's quite a faff getting it sampled onto a computer and then mixing it. Obviously, if it's already digitally stored, it's a lot easier to mix in. What does analog and digital sound look like? So on the left we have an analog sound wave, which is this means it takes the form of a continuous wave that changes smoothly. But as we've spoken about length, computers can only work with digital data. That's ones and zeros. So a digital sound wave looks like a lot of steps, which is effectively what it is. So sound travels as a wave. We've possibly seen this in physics before now. Travels as a wave. This is the movement of the wave shown in a diagram above on the slide. The amplitude of the wave controls how loud the sound is. The frequency controls the pitch. The amplitude is the movement from its undisturbed position in the middle, or zero. Here's another few examples of sound waves. The lower the amplitude, the quieter it is. The higher the amplitude, the louder it is. And then the longer the frequency, the deeper the pitch, and the shorter the frequency, the higher the pitch. Digital sound will sample the sound wave at certain points. These are represented by these bars. So after sampling, we are left with a digital version of the sound. So the analog one is the smooth wave, the digital one is the green bars, because obviously we can only represent ones and zeros or values like that. If we use a higher sampling rate, or like double it for example, we can represent the original sound wave much more closely. Increasing the sample rate will improve the sound resolution or the sound quality. If you lower the sample rate, it'll be crackly and it doesn't really sound very much like what it's supposed to do. Another reason why digital MP3s and stuff were popular is you could compress the file quite a lot. So if you increase the sample rate and the sample resolution, it gives you better sound, but it also means you take up more storage. So if you look at some of the streaming services, I'm telling you, there's one that Jay-Z announced, and all that was like the highest fidelity possible, which means what would have been an MP3 file at say 4 megabytes was now like 400, because the sample rate was as high as possible, so that the people who are into these sorts of things could get the best sound quality possible. But the price you pay is that you can only have, if it's 100 times more storage, then obviously it's going to be an issue. Quality versus file size. So each sample for a digital file takes up space. That's not really rocket science. The more samples you have, the higher the file size. So if at 800 megahertz sample rate, the file size would be 2.1 megabytes. If you went up to 44,100 megahertz for a sample rate, the file size would be 11 megabytes. So that's 5 times bigger and a bit more for the same song for the same amount of time that it would play on your device. The difference between file size and quality is very closely related. Have you ever noticed that the sound on some internet sites is poor? This is to help reduce the amount of time it will take to download things. Just a little side note, the sample rate is sometimes referred to as a bit rate. Now, I've talked long enough about this. Feel free to rewind the video if you think I've possibly skipped over something or you didn't hear it properly. All the slides are on there. Feel free to rewind it. And as always, there will be a couple links to BBC Bite Size added onto this. So your task this week is, tasks. Number 1, explain what sample rate means and why it's important when converting analog sound to digital. Number 2, explain what will happen to sound resolution if the sample rate increases. And number 3, explain why this change will occur in sound resolution when sample rate increases. Like I say, this is a video. Feel free to rewind it and watch it again and again as many times as you need to. There will be a couple of extra links for BBC Bite Size that go into more detail. Well, not more detail, just explain it differently, but are quite good. There's a little video on there as well. And as always, if you have any questions, feel free to give me a shout. Otherwise, I'll catch you guys next week. Take care. Bye.